This is the recording for Nursing 227 over Chapter 13, looking at calculating IV drug rates. And so this week we are going to be looking at how to calculate mils per hour, whether we are using a pump or whether we are going to be calculating drips per minute if we don't have an IV pump available to us. So a lot of times the physician or the provider will order fluids using a order such as 250 milliliters per hour. And so it's easy at that point to just enter milliliters per hour into your IV pump. But sometimes we don't have an IV pump available, and so at that point then we need to figure out how many drops we would want to be infusing into our chamber per minute to make sure that we're not giving the client too much fluid or that we're giving them enough and we're not under administering the fluid. Okay, so sometimes we'll give fluids intermittently, and oftentimes that would be some type of an antibiotic or a specialty fluid, and so we would oftentimes be using a pump in those circumstances. There are some rural locations, I think of especially ambulances, or if you were in some type of a disaster, and you may need to know how to calculate a drip rate without using a pump. And so when you think of drips per minute, it's a more accurate representation of what would give the client the most accurate dose. So we'll kind of be looking at if your provider orders something in milliliters per hour, and then we need to convert how many milliliters are in a drip, and that's always listed on your tubing. Your gravity tubing or your pump tubing will always have a drop rate per milliliter, and then you could convert the hours over to minutes. And so we're going to talk through the different steps that includes. Sometimes the provider may order a continuous fluid, so that would be this example here as 125 milliliters per hour. Other times they will maybe specify the amount of fluid and then the time that they want it to infuse over. So we had providers, especially the older providers that I've worked with, they will write 1 liter of whatever their fluid is over 8 hours. And so it's important to be able to understand how you would need to figure that out to understand what you're going to set your drip rate at, whether you have a pump or you're doing gravity. A lot of times when we use pumps, we use the pumps that will deliver a whole drop. And so those are most commonly what you're going to see on a medical or a surgical floor, on obstetrics. But sometimes when we have really specific medications, oftentimes within pediatric or neonatal settings, and then also within the intensive care unit, we would need to be using something called a micro pump. And that's just so that we can get a much more accurate dosage administered to a client. And so when we do problems like this, I may be telling you in the instructions of a problem on your quiz this week to round to the nearest tenth, and that would be an example of a medication that we would want to have on a micro pump. Okay, so let's look at our first example. Our order is to infuse 1 liter of D5W over 10 hours. The nurse should set the pump or controller to what milliliter per hour flow rate. Round the flow rate to the nearest whole number. So when we talk about how we need to start setting up our equation, my first thing is to always figure out what I'm looking for. And so the nurse should set up the pump or controller to what milliliter per hour flow rate. So since I know that I'm looking for milliliters per hour, I need to start out my problem down here with milliliters per hour. I don't put them on the same line because essentially when we have this per here, that means that milliliters is over the hour. So when I put that into an equation, I need to keep that together, but I need to have milliliters over that hour. So per is represented by this line, and that's what's making this an equation. I know that that's how I start my dimensional analysis problem. My next step is to put that equal sign, and then what I recommend you do is you write milliliters right here. So right now we've just got milliliters here. Then I would look up top of my problem and I would see what I'm given. And so I am given 1 liter. And so I know that I can convert milliliters to liters. So my next step would just be to put an L here. At this point, then I step back to make sure that I get the 1,000 in the correct spot. Sometimes oftentimes what I do is I would write on my quiz, 1,000 milliliters equals 1 liter. That's to make sure that I don't put the 1,000 down here and the 1 up here and get the wrong answer. So I've entered my first step. Now I know that I have liters here, so I need to go up, I need to make my time sign, and then I know that liters needs to be my numerator in the next equation. The only way I can cancel out liters and get to what I'm looking for, which is milliliters, is by putting something with liters up here on top. So when we look at the second step, then what we're going to do is look at that problem, and we'll see that the provider ordered 1 liter per 10 hours. So I put my liter up here, I looked at my problem, and I saw that the liter was over 10 hours. Again, this is an example of a marriage, and so your provider ordered 1 liter over 10 hours. You cannot separate that. You cannot put it in different parts of different equations. 1 liter has to be combined with 10 hours. So when we look here, we have 1 liter over 10 hours. Now, how I knew to put 1 liter over 10 hours and not 10 hours over 1 liter was because I started setting up my problem correctly, and I knew I had liters here, so I had to have liters on the top of the next one to cross them out. So then I go ahead and I complete my equation, and I receive an answer of 100 milliliters per hour. Now, if the directions on this problem on Blackboard told you to solve to the nearest tenth, you would not add a 0 after this and do 100.0 just because the problem told you to round to the nearest tenth. That just means if you receive an answer in your calculator which is multiple decimals, at that point, then you would round to that tenths place. But when you receive a nice answer like this, you're not going to ever add that 0 to the end. That's against one of our Dakota Nursing Program math rules. Okay, let's look at another problem. So we're going to infuse 500 milliliters of 0.9% normal saline over 4 hours. The nurse should set the pump or controller to how many milliliters per hour flow rate, and we're going to round to the nearest whole milliliter again. So our problem tells us, what are we going to set the milliliters per hour to? We're going to enter milliliters over hour here because that's how it is in the equation. What we always do is look at this first numerator and what we're looking for. So we have milliliters up here, and my first step is knowing that milliliters goes right here. Then what I do is I go and I look at my problem, and I look and see what has milliliters in the problem that I can use. And I see right here, 500 milliliters over 4 hours. So even though this is a little bit longer of a sentence, it has to stay together. That 500 and that 4 hours has to stay together because that's what your provider is telling you to do. So I can do 500 over 4 hours. And in this example, we don't need to add another conversion step. And so we would be able to do the math, and we're given 125 milliliters per hour. Next, we are going to have some practice problems. So I would let you guys do these on your own. I'd like you to make sure you're very comfortable with this way of converting a prescription to a milliliter per hour flow rate. Okay, so when we're looking at intermittent infusions, such as oftentimes antibiotics or things like that, we will follow the exact same way to complete the problem and do the equation, but oftentimes it's just not going to be as much time. So those will usually run over 15, 20 minutes to an hour. You have a smaller volume usually. So an example of that would be if a prescribed dose would be 350 milligrams diluted in 100 milliliters over 90 minutes. At what milliliter per hour flow rate should the nurse set the pump? Now, when we look at this, the provider ordered 350 milligrams. And that actually is a little bit of extra information in this problem because we're figuring out the milliliters per hour to be given, and our provider told us how many milliliters we wanted over 90 minutes. This 350 milligram step would be important when you were doing your 3 checks at the bedside to make sure that you had the correct dose, the correct route, the correct patient, all of those medication safety things. But at this point, when we're just looking at how many milliliters per hour, we don't actually even need to know how many milligrams are included. We're going to get to problems where you'll have to figure that out, but at this point we don't even need that. So we know that our problem asks for milliliters per hour. We've got milliliters per hour here, and we have to start out that problem with milliliters. So we know that that provider tells us that we need to give 100 milliliters over 90 minutes. Okay. So we can't put 100 milliliters over an hour, even though we were looking for an hour, because that's not how our provider ordered it. So we're going to do 100 milliliters over 90 minutes, and then our next step would be figuring out that we need another equation here to get rid of minutes and convert to hours. So we would write minutes right here, and then we would fill in what we need to do. So when you look right here, we've got minutes, and then I would write over hours, and then I fill in my 60 and my 1. Okay, when we put that into our calculator, 100 times 60 divided by 90, you would get 66.7. If we look back at our directions, it said to round to the nearest whole number. So your answer then at that point would be 66 milliliters per hour. All right, and this just kind of says again that that dosage was actually unnecessary, and we check it for accuracy at the bedside, but it's not used to calculate the flow rate in this instance. All right, we've got one more example here. We're going to give 750 milligrams diluted in 50 milliliters over 30 minutes. What is the milliliter per hour flow rate that we would like to set the pump to? So we know that we're looking for milliliters per hour. We're going to set it up with milliliters per hour here. We know that our first equation needs to have milliliters as the numerator because that's what this first equation is. What does our problem have that includes the milliliters in information that we're given? Our provider says that we're going to give 50 milliliters over 30 minutes. So I've got 50 milliliters over 30 minutes. In this problem, we're looking for hours again. So how are we going to do that? Then we're going to add another step in here. We can't take 50 milliliters over 60 minutes because we know we want hours when we look at this denominator of the answer. But since the doctor ordered 50 milliliters per 30 minutes, we have to keep that together. We have to keep that intact. We can't just swap hours in or we won't get the right answer at this point. So we need to keep going, and we're going to then put minutes up here, and we know that 60 minutes equals an hour. When you look at your reduction then, we see that both minutes are crossed out, and then we're left with milliliters per hour. When we go through and put that into our calculator, we're given the answer of 100. So we have 100 milliliters per hour would be the rate of administration. I have some more practice problems provided for you here. Now we're going to look at syringe pumps. And so again, syringe pumps are a little bit more accurate, and they have a smaller amount of fluid, and it is in a syringe like you would give an injection with. It's just usually a larger syringe, 35 to 60 cc's, and we use this in more acute care areas where we've got smaller volumes. So we use these in the nursery routinely and in pediatrics. So our order might be to infuse 100 milligrams diluted in 5 milliliters over 15 minutes. At what milliliter per hour flow rate should the nurse set the pump? And here we want to round to the nearest tenth. So this would be an example of that micro type of a pump where we can deliver a more accurate dosage, and so we're going to round to that first decimal or that tenths place. We're going to use the exact same process we've been using. So our problem asks for milliliters per hour flow rate. So here we've got milliliters. Again, this line in the middle suggests your per in the verbal equation, per hour. And since we have milliliters here as the numerator, we know we have to start out with milliliters here as the numerator. So what do we have in our problem that talks about milliliters? Well, we have 5 milliliters over 15 minutes. Again, that was ordered together. That can't be split up. It has to remain together. So we have 5 milliliters over 15 minutes. Again, we have minutes here, and our pump is using settings of an hour. So our next step would be to go ahead and figure out what else we know about minutes. Since minutes is here, we know minutes has to be the numerator in this equation, and we know that there's 60 minutes in an hour, so that's our conversion factor. When we take 5 times 60 divided by 15, we get 20. This is that example where the instructions said to round to the nearest tenth or first decimal, but our problem yielded a whole number, so we would never add and write 20.0. Our answer would still be 20, even though the problem instructed to round to the nearest tenth. I have another example here I'm going to let you do for practice, and then we've got some additional ones here in your PowerPoint. When we look at completion times, there's a couple of extra steps, and so this is something that students oftentimes will want to practice a little bit. And so what this is used for, especially if we're using a gravity line of infusion, we want to make sure that the fluids aren't going too fast or too slow. And so it's important to keep a really close eye on them and to make sure that you know when your fluids should be finished. So in this problem, we want to calculate how long it will take for an IV that's infusing at 150 milliliters per hour, and there is 250 milliliters of fluid left in the bag. Right now, the time on the clock is 10:30 a.m. When will this IV be completed? And so here we can use dimensional analysis to gather information to help us make sure that our client is getting the fluid administered at the correct rate again. So we always need to start out with what we're looking for. And when we look at this problem, it says calculate the infusion time. So we know we're looking for time. And when we measure time as far as in this problem, we're using hours because we have hours already in our program. So we're looking for hours. Since we're looking for hours, we know that hours has to go here. So this is what I would say is just write hour up here at this point. Then look up to your problem and look and see what do you have that includes hours. Okay, you might be looking and seeing, well, I have 10:30 and that's a measurement of time. Does that go there? It doesn't go there, and the way you can remember this is that it's not married to anything or with anything. We just have 10:30, and we need to have an equation at this point. So we know that we have hours here, and so we have 150 milliliters that's going to be infusing every hour. So we can put 1 hour over 150 milliliters. What we need to do then is think about what our next problem step would be. And so we have milliliters here. We know that we need to continue with our milliliters. Our problem tells us we have 250 milliliters. So what we could do then is just go ahead and take 250 divided by 150. And you are going to get an answer of 1.66. And that's great, but what is 1.66 or 1.67 hours? Here's an example where for greatest accuracy, you could round to 1.67 because 1.666 is going to keep going. So we have 1.67 hours, but we don't measure time that way. So now what we need to do is take the first step and identify that this one does identify 1 hour being 60 minutes. But this 0.67 does not represent 67 minutes. Okay? So what this represents is 67, what is 67% of an hour. So the next step that we need to do is convert this hour into minutes. And so that means that we're looking for minutes, okay? So we're going to put minutes right here. We know that there's 60 minutes in an hour. We have hour down here, and our problem has 0.67 hours. So what you would do then is take 60 times 0.67, and you get 40.2. Now, we don't measure time in seconds when we talk about medication times, unless your directions specifically tell you to. So here's where we would use our rules of rounding, okay? And we would be looking then at 40 minutes. You would round down to 40 minutes. So 1.67 hours equals 1 hour and 40 minutes. The problem would tell you to include your time with that label. if it was indicated, and you would be also instructed to enter a completion time, because it gets confusing if we would want you to enter, exactly like this in Blackboard. So then what you would need to do is, as your last step, take the starting time, which was 10:30, and then you're going to add an hour and 40 minutes. So what you would type into Blackboard, it will tell you to enter the answer in military time. So you would type just simply 1210. You would not include, as I showed in parentheses, you would not, oh, excuse me, I'm just trying to make a pointer and I think I did it wrong. You would just enter 1210. As you show in parentheses, you would not enter an answer like this. So let's do one more like that. Calculate the infusion time for an IV that's infusing at 50 milliliters per hour with 400 milliliters of fluid left in the bag. The current time is 3:45 in the morning. When will this IV be completed? So again, we know that first of all we need to figure out how long is this infusion going to take. So we're looking for hours. How many hours will it take to infuse this 400 milliliters? Since we are looking for hours, we have to start our equation up here out with hours. So when we look at what the prescriber has ordered, they have ordered it to be infusing at 50 milliliters per hour. So we'll have 1 hour over 50 milliliters. Since we have milliliters here in the denominator, we need to make sure and have milliliters in the numerator of our next step. So that would be accomplished with entering then your volume left of fluid. 400 milliliters of fluid left in the bag. So you would just take 400 divided by 50 and you receive an answer of 8 hours. This is a little bit easier. You would just take 0345 plus 8 and your answer would be 1145. And again, that's exactly how I will ask you to enter it into Blackboard this week without any PM, AM spaces or colon. Here are some practice problems for you. And now we're going to move on to drops per minute. This is personally one of my favorite things to do. We use this again when we're using gravity tubing, and so what you would need to do is count over a minute and physically count how many drops are dropping into that drip chamber in the time of a minute. And so the provider is going to order a dosage per hour. You need to convert it to minutes, and then you also need to know what your drip factor is, because the drip factor of tubing will vary depending on manufacturer. So that will be found right on that outside bag of your IV tubing comes in. It'll tell you the drip rate. This week when you're at clinical, I challenge you to just look at the bags that are available within your facility and see what is the drip rate of them. We need to make sure that we're monitoring very carefully, because we can easily infuse too much fluid too fast, and so that can really cause problems with the client. Some of the ways that you can increase the rate that fluids are infused if they're under gravity control would be if you open that clamp too far. There's that white roller clamp, or usually it's some type of a roller clamp. If you open that too far, if your IV pull is raised up as high as it can go, that will increase the rate of administration. If you put the bag lower, closer to the insertion site, that will slow down your rate. You also will be able to see that the rate will be affected depending on the location of the IV. If it's in the antecubital or in the wrist and the client moves that location, a lot of times that will occlude the infusion, and so it won't be infusing. And then that's the other problem. If your client's dehydrated or they're getting an antibiotic and they're not receiving it as they should be receiving it in the allotted time frame. So we don't want it too fast or too slow, and so there's a lot of management and assessment that comes with gravity infusions. Okay, so let's go ahead and look at some problems. We have an order where we're going to give 500 milliliters and we are going to give that over 6 hours. The IV tubing has a drop factor of 20 drops per milliliter. We need to calculate the drops per minute flow rate. All right, so I love this. It tells us drops per minute. That's what we're looking for. We have drops over minute. So that's what we're going to start out our problem with, drops over minute. We have drops here in the numerator. That means drops has to go here in the numerator. Always going to start out with what you're looking for on top. So let's look up to our problem and see what do we have that includes drops. And we have here our IV tubing says that there's 20 drops per milliliter. There's nothing else in the problem that even gives us drops. So we have to, that's our only number to choose from there. We know that it has to go with 1 milliliter because this is that equation. The manufacturer of the IV tubing says 20 drops equals 1 milliliter. We can't change that. We are not manufacturing new tubing, so that has to stay together. We have 20 drops per milliliter. Then what we need to do is identify that we have milliliters here. We need to move on to milliliters up here. So we're looking for something with milliliters from our problem, and we know that the provider ordered 500 milliliters over 6 hours. Again, the provider didn't order 500 milliliters over 3 hours or 60 minutes, so you have to keep that together exactly as the provider ordered it. 500 milliliters needs to stay with 6 hours. We know that 500 milliliters goes on the top and 6 hours goes on the bottom because we have milliliters here, and we know that milliliters then needs to be up here or we won't be able to cross those out. And we're not looking for an answer that includes milliliters, we're looking for drops per minute. So then what we're going to do is just take 20 times 500 divided by 6. Oh, excuse me, I missed a step. So we're left with hours here. And our problem is not looking for hours. If we were using an IV pump, we would maybe want hours, but we're using gravity, so we're looking for minutes. So my next step then up here is to identify that I need to get rid of this hours. And so the way to get rid of it is to put hours up here as well. And I can convert hours to minutes in one equation, so it would look like this then. We have 1 hour over 60 minutes. Then we'll go ahead and take 20 times 500 divided by 6 divided by 60. We're always dividing by anything on the bottom. You're multiplying anything on the top. And you would receive an answer of 27.7. The instructions on the quiz will tell you if they want it rounded to the 100th, the 10th, or the whole number. This said the whole number. When you think about drops per minute and you're counting a drop, it would not make sense to have anything besides a whole drop because you're literally counting that drop falling into the chamber. And you can't count a 10th or a 100th of a drop. So if we're ever calculating drops, even if the instructions don't tell you, it needs to be a whole number. So you would round 5 and greater, you'd round up. And we have a 7, so we would round this to 28 drops per minute. All right, we have one more example. We have 1 liter to be infused over 12 hours. Your IV tubing available has a drop factor of 15 drops per milliliter, and we need to calculate the drips per minute flow rate. Okay, so it tells us drips per minute. We're going to put drips over minutes. Drips per is represented by this line, minute. We are looking for minutes, and our answer here is the numerator, so we have to put drops here. Let's look up to our problem and see what do we have that includes drops. Our tubing drip factor is 15 drops per mil. Again, that has to stay together, so we have 15 over 1 mil. I knew that 15 needed to go on the top because I am looking for drops per minute, and you're always looking at this numerator of what you're looking for, and the numerator of what you're solving for has to be the numerator of your first equation. So that's how I understand what goes on top and what goes on bottom. Next step then is identifying that we have 15 drops per milliliter. We want to get rid of milliliters somehow because we're not looking for milliliters in our answer. So we're going to go ahead and put milliliters up here. Then we're going to look to our problem. And our problem is talking about liters. And so we can't just put in liter here without inserting the conversion factor. Because when you look at the problem, it says 1 liter over 12 hours. So one way to do this would be to underline this or to write this together on your scratch paper. 1 liter per 12 hours. That is how the prescriber ordered it. That can't be separated. So we can't just put 100 milliliters over 1 liter and then think that we're using this liter here from our problem, because that's just simply our conversion step to change liters to milliliters. Okay? Then what we need to do is again, we need to solve and get rid of this liter here, because again, we're looking for drops per minute. We can look up to our problem and see that our provider ordered 1 liter over 12 hours. So again, I have liters down here. That's why liters had to go up here. Then we can just go ahead and put that in our calculator. We would take 15 times 1,000, and then you would divide by 12 and divide by 60. You get an answer of 20.08. Again, we can't have a partial drop, so you would round. This is 5 or greater, so we would round up to 21 drops per minute. Here are some additional problems for you to complete for practice. And we are going to do kind of the same type of a problem, just a little bit of a different way here. So let's look at drops per minute flow rate for a fluid infusing at 125 milliliters per hour. And we've just got a different drip rate. And so this is where it's important to either look at your IV tubing bag and know what the drip rate is, or to look at your problem, in this case in your quizzes, will tell you what your drip rate is, or what your drops per milliliter equation is. So we're looking for drops per milliliter. Calculate drops per minute. Drops per minute is what we're told to calculate. So we have drops over minute. We have drops here in the numerator of what we're looking for, so we have to start out with drops here. That's the only way I know what goes on top and what goes on bottom, is by looking at what you're solving for and starting out your problem with that. So our tubing, or our problem, tells us that 10 drops equals 1 milliliter. So we're going to go ahead and enter that. Again, I have milliliters here, and I don't have milliliters in my answer, so that means I need to find some more information from my problem so that I can eliminate milliliters. I look up at my problem, and I have 125 milliliters per hour. Since I have milliliters down here, I know milliliters needs to go up in the numerator of this next equation. Then we are left with hours, and our problem wants minutes. So we're going to go ahead and we need to convert hours to minutes. So we can take, and we have hours here. We know hours needs to be up top then, and we have 1 hour over 60 minutes, and that's your conversion factor. So we have 10 times 125 divided by 60, and we get 20.08, and that equals 21. Okay, I think a couple more problems like this that you guys can do for practice, and just make sure that you're comfortable with converting these. Okay, we're going to do another completion time one. Calculate the infusion and completion times for an IV that's infusing at 42 drops per minute. 1,000 milliliters of fluid remain in the IV bag. The drop factor of the tubing is 15 drops per milliliter, and the current time is 0 to 100. So again, we're looking for what are we solving for? And so calculate the infusion and completion times. So let's start out by calculating that infusion time. We need to first calculate the infusion time, and then we can add that to the current time, and that will be our completion time. So infusion time is in hours. We're measuring in hours, and so we are looking for hours. Hours is then always going to be represented as the numerator of our first equation. And we need to think about what we know about hours. And so when we look at the problem, we're talking about drops and milliliters. We've got drops and minutes. We've got milliliters. Nowhere do we have hours. However, we know that we're starting out, we have minutes, and so we have that unit of time. So that's how we would know that we needed to right away start with our conversion step. And so you would have 1 hour over 60 minutes. Since we have minutes down here, we know that we need to have minutes in this next numerator. So what we would do then is take 1 minute over 42 drops. We're getting this right here, that this is what the IV is infusing at currently. This is again that standard piece of information that can't be split up or separated. And then we need to know what the drip factor of our tubing is. And so our drip factor is 15 drops per mil. I know that 15 goes on top because I have drops down here, and I need to have drops up here then. I can go ahead and I can cross out all of my labels that are able to be eliminated, and we would take 15 divided by 60 divided by 42. And one more step again that I'm missing. So we are looking at that extra piece of information in the problem. they're telling us that there's 1,000 milliliters of fluid remaining in the bag. Okay, so we're going to go ahead and we have milliliters here, and they were nice and said 1,000 milliliters, so we don't even have to convert liters to milliliters. So we need to use that last piece of information. So then we would take 15 times 1,000 divided by 60 divided by 42, and we receive an answer of 5.95 hours. Again, this does not mean 95 minutes. It does not mean 5 hours and 95 minutes. It means 95% of an hour. So we need to convert 0.95 hours into minutes. Again, to do that, we would say that we're looking for minutes. We're solving for minutes at this point. You would take 60 minutes over 1 hour, and then you need to enter your 0.95 hours. You would take 60 times 0.95 and you receive an answer of 58. So you had the 5 hours from this step, so you would keep this 5 hours here, and then you're going to enter your minutes. So we have 5 hours and 58 minutes. That's our infusion time. Current time is 0 to 100. So to get our completion time, we need to take our current time plus our infusion time. So we would essentially just add 5 hours to 2. We get 7 hours, and since it's right on the hour, it makes it really easy, and we just add our 58 minutes. So 0758 would be our completion time. Again, you're always going to answer the question with military time without any labels or semicolon present, or colon, I should say. When we look at this example, let's look at an IV that's infusing at 36 drops per minute. We have 150 milliliters left in the bag. The drop factor of the tubing is 60 drops per milliliter, and it is currently 1320. Okay, so again, we're looking for our infusion time. We have hours here, so we know we have to start out with hours here. We know that there's 1 hour is equal to 60 minutes. We can put in that conversion factor, and then we can look at our problem and we can see that there's 36 drops being administered per minute, and then we need to look at our drop factor for our tubing, and we have 60 drops per milliliter. And then finally we need to look at the volume of solution, and our volume of solution then is 150 milliliters. So we can take 60 times 150 divided by 60 divided by 36. And what we get then is an answer of 4.17 hours. So we have 4 hours, and then again we need to convert this 0.17 hours into minutes. So we're looking for minutes. We're going to start out our equation with minutes here, and we know that we need to have minutes up here. I know that there's 60 minutes in an hour, so I can go ahead and insert that, and then I'm going to multiply by this 0.17 hours. So I take 60 times 0.17, and I get 10.2 minutes. We weren't told, that we were going to be needing seconds in the problem, so of course we would round again to the whole minute, and so we have 10 minutes. So you would just take 1320 plus 4 hours and 10 minutes, and we would get an answer of 1730. Again, you're not going to write in 5:30 and then add in a PM. You're going to type in military time without any spaces or colons, 1730. All right, so I've got some more practice problems for you there. And then what we're going to do now is talk a little bit about time tapes. And so a time tape is a way for the nurse that's infusing fluids via gravity to keep an eye on if they're going too fast or too slow, and to just use as a double check to make sure that that dose is remaining accurate. And so these often come from the manufacturer, and they're already marked, and there's something that either are sticky and they just stick onto the bag, or you may tape them onto the bag. And so what we would be doing then, what we're going to be doing now, is looking at the IV rates and going drops per minute and mils per hour. You would use a pen and you would write on the tape. You want to make sure not to write on the actual IV bag, because we don't want it to potentially leach through the plastic and into the fluid. So you're always just going to write on that tape itself, and then you would write on the bottom of the tape the time that you expect it to be completed, or that end time, and then also the date if it goes to the next day. All right, so a lot of times you'll make little hash marks and you'll note what hour the fluid should be where, so that each hour you can pop into the room and make sure that there's not double the amount of fluid that's gone or not enough fluid that's been administered. Here's an example of what a time tape might look like. And that is the end of this presentation over Chapter 13 of Horntvedt. Have a great rest of the day.